All right, so for recording purposes, today's topic, well, we're starting off with alkanoic acids. So we have our first picture puzzle just for today. How this works, right? I'm going to give you three pictures, and all three pictures are trying to tell you the same thing. All of them are depicting a certain word. And this word is a 5-letter word, and the second to last letter is T. What word do you think they're trying to depict in those pictures? Samir, correct. So the word was supposed to be empty because all of the items there, look at it. It has it's depicting something empty, an empty book with nothing written in it, an empty box, or an empty cup. But anyway, this is the first one. It is just the the teaser, right? The rest of them are much harder. So let's start off with the general formula of alkanoic acids. And you will know an alkanoic acid a mile away, right? It has the very famous COOH. You cannot miss that, right? So when you see that COOH, you know it's an alkanoic acid. And here's the general formula, right? To calculate the amount of hydrogens based on the amount of carbons. You all know how the formula works already. Like if you just replace N with a value, and of course, from that point, you can what? Calculate the amount of H's. Right. So alkanoic acids usually ends with the phrase anoic, and of course, you put the word acid after. So the first one has one C, one carbon. So by now, everyone knows it's what? Meth, since it's one carbon, and all alkanoic acids would end with anoic. So this is methanoic acid. You think you can do the next two for me without looking in your books, right? Just name and look at it, the COOH, right? You just know it, and when you draw it out, this is the COOH part here. That's this guy here, okay? And one of the O's has a double bond in it. It's real easy to spot. Right, so Samir, you have both there, right? So the third one has three C's. 1, 2, 3. That's propanoic, right? Remember, prop is what? 3 carbons, and then you put the word acid. Easy stuff. And the simple things like this do come in the exam, but you get 1 measly mark for it. You can't expect too much. The next one, the last one, I think a few people counted it wrong, or I could be going blind, but let's see. 1, 2, 3, 4, 5. Now, it's not hex. This one is pent. Pent is 5. Pentanoic acid. Easy, easy, easy stuff. Cannot go wrong with that. Great. So let's move on. Like I said, you don't have to make much notes today. Today, just providing answers, right? So guys, for those who quiet, come on, push some answers, right? So let's investigate some reactions of ethanoic acids. Now, there are two main categories. One called anhydrous. Anhydrous means, when you hear the words anhydrous, it means no water. Well, no water, at least at the beginning of the reaction, right? And when you hear aqueous, right, sorry, it means with water. Now, I want to stress on something, right? Anhydrous doesn't mean the entire reaction has no water. Nobody said that. Anhydrous just means at the beginning of the experiment, when you're now mixing things together, there's no water involved. Aqueous, sorry, I said aqueous, sorry. Aqueous, sorry. I don't know what's wrong with me today. Means with water. Okay? And you can have it, and it's usually at the beginning of the reaction, you will see some water. Now, a lot of people, how you say, whenever they see something liquid, for some reason, I don't know why, whenever they see a liquid, they always assume it has water in it. So, for example, if I get a container, let me fill this container, let it be a flask, okay? And I pour ethanol into it. Remember last week we did alcohol, so ethanol is a type of alcohol, specifically with 2 carbons. So we fill this with ethanol. Now, ethanol is really clear, but obviously I'm not going to draw it clear. Does this ethanol, being a liquid, does it have any water in it? Does ethanol have any water in it? It's a liquid, and does it have? No problem, Fionn. What do you guys think? Ethanol, liquid ethanol, does it have water in it? Right, and the answer is no, right? It has no water in it. Being a liquid does not mean it has water in it, right? And you might think I'm stressing on that, but I've seen plenty people make that, I don't know, wrong, that mistake, right? So let's go with the anhydrous reactions first. Let's do that. But first, let's do a quick review on something on acids. We all know that there are strong acids and there are weak acids, okay? A strong acid, when you dissolve it in water, right, it disassociates. For example, if I have some water here and I throw some HCl into the water, right? So you get hydrochloric acid. We all know hydrogen is ionically bonded to chlorine. I know hydrogen is not a non-metal, right? But hydrogen, as I mentioned in the first term since September, hydrogen is a wannabe metal. He is not a metal. We all know hydrogen is not a metal, but he likes to pretend he's a metal. So hydrogen is actually ionically bonded to chlorine, even though both of them are non-metals. That is how hydrogen is. When let's say we put 3 molecules of HCl into water, it will dissolve. And when things dissolve, they disassociate, meaning that the H plus ions will become separate from the Cl ions. Now, but remember, we said we put 3 molecules. You notice what happened? All 3 molecules disassociated. In all of the molecules, the hydrogen was separated from the chlorine. And this is what we call a strong acid. A strong acid is when everything gets disassociated. However, right, here we have a very weak type of acid. It's probably an acid you're not normally, you don't normally come across. The name of this acid is actually ethanoic acid. And you know remember, ethanoic acids are still acids at the end of the day, right? And we call it ethanoic acid because it has 2 C's and you see the COOH. So it's a type of alkanoic acid, specifically ethanoic acid. Now let's do the same thing. Let's take 3 molecules of ethanoic acid and we dissolve it in water. Look at all of them. It have 1, 2, 3. You see the CH3OO part up to here before the H? He actually has a negative charge. So he's kind of like ionically bonded to the H. But not all 3 disassociate. You notice the first one stay together. The last one stay together. Only the middle one disassociated into a positive and negative charge. This is called a weak acid. A weak acid is when there's not total dissociation. Some disassociate, and some of them say, nah, I am not disassociating. Right now, I know we did this last term in October, but it was worth, how you say, mentioning again, because it's going to take part later on in the rest of the slides. So let's move on, right? So anhydrous reaction. Well, the first anhydrous reaction of alkanoic acids, the one you have to learn off by heart for the exam, right, is that whenever you take ethanoic acid, which is this guy here, now you know I'll put the letter L here, but this is supposed to be L to show it's a liquid, right? But you don't usually write it here. You just kind of write it below the H. So sorry about that. So when you take the ethanoic acid and you mix it with oxygen, so ethanoic acid, you could burn it in air or oxygen. And when you do that, you get three things: carbon dioxide, H2O, but it's G. So this water is actually what? Steam, okay? And then this, this by now is a symbol for what? Exothermic, meaning that heat is produced. Now, I just want to point out, this is an anhydrous reaction because look at what we started off with. When we started off, do you all see any water here? Do you all see any H2O? The answer is no. Now, don't get me wrong. After the reaction, we got some water. Well, H2O at least. But at the beginning, it had none. Because this L here means it's a liquid. But ethanoic acid, even though it's a liquid, it doesn't have any H2O in that. It's just pure ethanoic acid. So that's one type of anhydrous reaction. And take my word for it, guys, memorize that for the exam. You don't already have a choice, okay? The next one now, which we will get to later, is the production of esters. Whenever you take an ethanoic acid, which has no water in it, and you mix it with an alcohol, which also has no water in it, at the beginning, hence it's anhydrous, you get something called esters mixed with water. But that water comes after the reaction. We will be spending a lot of time on this one in about 45 minutes, but I just mentioning it now. So let's move on. So the opposite of the anhydrous reactions, right, will be the one with water, right? We'll get to that just now. So let's see the clue for this one. We have, what word is this? It's supposed to be a 1, 2, 3, 4, 5, 6, 7 letter word, and the fourth letter is V. What is common with all of these words? What word are they trying to do? I think I'm making this game too easy. I should probably put 2 pictures next time. All right. Everybody seems to be getting it correct. Get some calming music in the corner there. I promise you it will get harder. This one is supposed to be nervous. Look at everyone in the picture. They're nervous somehow. All right, let's go. Right, so the opposite of anhydrous is the aqueous reactions. All of them involve water. Now, I want to explain this, right? Because this could be hard to memorize if you don't notice the pattern here. Well, so what we're going to do now, we're going to take ethanoic acid and mix it with a reactive metal. The one we're using for this example is magnesium. Now notice this, you have 2CH3COOH, right? That is ethanoic acid, but I don't have the letter L anymore. Look at it, I have AQ now here. That means that this ethanoic acid is not pure ethanoic acid. It has been mixed in a little bit of water. And we're going to mix that with magnesium, which is a solid. Now, and I think I mentioned this, right? But I want to write back this big. the CH3COOH, right? I know I mentioned this. Remember, this has a positive charge. The hydrogen has a positive charge, which means the whole remaining structure here obviously has what charge? -1. Because if this is +1, then to balance it off, the entire remaining structure must be -1. So the two will balance off to get what? 0. So when you mix it with magnesium, what's going to happen? The magnesium is going to try to take the place of the hydrogen. He's going to try to kick hydrogen out because magnesium is more reactive than hydrogen. And it happens over here. Look closely, and this is kind of difficult to see. You notice afterwards, the magnesium takes the place of what? The hydrogen. The hydrogen is no longer here. But remember, magnesium is a group 2 metal, which means that if this here has a charge of -1, if CH3COO has a charge of -1, and then magnesium takes the place, and he has a charge of +2, then you need 2 of these guys to balance off 1 magnesium. Everyone okay with that? Because if the charge of one of these is -1, you need 2 of them to make the overall charge -2. So you got to be careful. Huh? If it was potassium, the potassium would not have made a fuss because potassium is in group 1, just like how, and he would have a charge of positive. So if potassium came here, right, I just say, if potassium came there, right, no 2 would be required there, right? No 2 would be required because potassium is a group 1 metal. All right, so you have to memorize this, well, how you say, general structure. An ethanoic acid plus a reactive metal will give you salt and hydrogen. The name of this salt is magnesium ethanoate. And we all know salts end with ate, A-T-E, right? Right? So that's a common ending for salts. The other one is ethanoic acid plus oxides or hydroxides will give you salt and water. And here we have a very similar situation. The copper is going to try to take the place of the hydrogen. Copper, a lot of the times, copper has a charge of +2, right? So when the hydrogen gets kicked out, he will go meet the oxygen, and 2 of them will form H2O, right? Number 3, let's see what's going on here. Ethanoic acids plus a carbonate or a hydrogen carbonate, right? But I use a carbonate for my example here. If you look at it, I have sodium carbonate. When you mix these two together, you get salt, water, and carbon dioxide. And sodium is a group 1 metal. So when he kicks out the hydrogen, as usual, you don't need 2 of this. You notice there's no brackets over here, right? So it's just 1 sodium to balance off 1 of these guys here, right? Great. How much of you think you're going to have problems memorizing those 3 things in the exam? The only way you're going to memorize this is every other or every 2-3 days is pull out a blank sheet of paper and try to write this from memory, right? And you have to remember the state symbols and whatnot. And all of them, if you look at it, have AQ. All of them start off with some sort of water, making it an aqueous reaction. All right, so let's move on. Right. Now, this is a random slide out of nowhere, right? Just something I needed to pinpoint. how much homologous series have we done as yet? I'm using a fancy word there. But remember, we did things like alkenes, alkenes, alcohols. Today we're doing what? Alkanoic acids. Each one of them is a type of homologous series. So alkanes is one type of homologous series, and it have many different types of alkanes. Alkenes is another type of homologous series, and there are many different types of alkenes and so forth, right? And what do we notice with all of them? All of them contain some functional group. For example, alkenes. What's special about alkenes? Alkenes normally have what? A double bond in between two C's. You call that a functional group. A functional group is something that is stand out about that particular series. What about alkanoic acids? Well, we saw alkanoic acids have a COO, right? That's our, I'm gonna draw it for you. You all notice all alkanoic acids have this in it, or better known as the COOH. That's the functional group of an alkanoic acid. Who could tell me what's the functional group of an alcohol? What stands out about an alcohol? What makes you think it's an alcohol when you watch it? Correct, and the answers are springing up on the screen. OH. It always ends with OH. Don't mix it up with alkanoic acids. Alkanoic acid has a CO and an OH. So it's different from alcohols. And alkenes, the very first one we did, there's nothing really special about it. All I can say about alkenes, it is only have single bonds. And it's very boring, right? So I don't think they're going to ask you about the alkenes functional group because there's nothing really that stands out about alkenes. It's just boring. All of them have a general formula that you need to learn off by heart. Like, for example, alkenes was CnH2n. The members of a group have similar chemical properties and reactivity decreases as the amount of carbons increase. So all of them, it doesn't matter if you are an alcohol, an alkene, an alkanoic acid, or an alkane. The more carbon you have in you, the less reactive you are. And the good thing about it, all alcohols have a certain way of reacting. All alkenes have a certain way of reacting. So they have similar what? Chemical properties. The physical properties show graduation. Like this one might be hard to understand, right? As the amount of carbon atoms increase, so does density and boiling point and melting points. Let me explain that with an example. So let's take alkenes. We all know alkenes start off with what? Methane, then ethane, then propane. As we go down, right, the amount of carbons increase. Now, as the amount of carbons increase, gradually, that's what the word graduation here means, gradually their density, boiling point, and melting points will increase. So that means propane is denser, has a higher boiling point, and a higher melting point than ethane. And of course, similarly, when ethane is compared to methane, you'll realize that each member only differs by the previous one by 1 C and H2. Like the difference between methane and ethane is that ethane will have one extra carbon and 2 extra hydrogen. That's a general pattern. And propane, similarly, he will have 1 extra carbon and 2 extra hydrogens than ethane, right? And the members of a group can be prepared using similar methods. So if you want to make methane, ethane, or propane, since all of them belong to the same homologous series, in other words, all of them belong to alkanes, if you want to make them, the procedure to make them, any one of them, will be basically the same, right? So, and for the exam, I know I give you 6 things to notice about homologous series. The most I have ever seen asked in an exam is 4. So my advice is learn off any 4, right? If you can't memorize 6, just memorize 4 for the exam. All right, so let's move on. Now, the one that causes trouble, esters. Now, I'm going to make you draw back everything here today on esters, only because it's so complicated, right? So everyone get your scrap sheets of paper, and I want you to write back whenever we do an example or write it, I want you to write it back here. It needs to stick in your head. This is something that never sticks in most people's head. So this here is a very complex formula for esters, all right? It's a little bit harder, meaning that if you replace this now, this n with 3, you have to replace this n with 3. And then x is a totally different number from n. So if you replace this with 4, then you have to replace this with 4, right? So don't mix up the n's with the x's. So guys, you'll have to memorize this formula. I want everyone to take down, on scrap, just take it down. And no harm in writing it. I want it to stick in your head. This here is a general reaction to make an ester. You want to make an ester? No problem. All you need to do is take an ethanoic acid, any kind of ethanoic acid, mix it with alcohol. But you just can't mix the two together and hope they make an ester. You also have to apply heat and concentrated sulfuric acid. So those are the conditions that push the reaction to happen, right? And when you do that, you get something called an ester, and you get what? Water, right? Now, when you're naming esters, since an ester is made by combining an ethanoic acid and an alcohol, when you name the ester, piece of the name will come from the alcohol used to make it, and piece of it will come from the ethanoic acid that was used to make it. The alcohol prefix, the name starts with the alcohol prefix. Don't worry, I'll explain what you'll remember what the prefixes. Eth, meth, prop, bute, pent, hex. Those things are prefixes. And the alcohol part of the name comes first. And it will always end with YL, space, and the ethanoic acid prefix will come after and end with anoate. Right. Take down everything. Take down everything. Let me know when you are finished. Even though it's scrap, still write it neat. When you write things or practice the write things neat, your brain memorizes it better. All right, so here we have an ethanoic acid mixed with alcohol. We're mixing it with alcohol. Do me a favor, take down everything here, then I'll explain it, right? So draw everything neatly, and I will come in, well, I think 2 minutes should be enough, and I want to explain it. Now, when it comes to alcohol, right? This here is the alcohol part here. There's one, guys. Let me get red. Right. This here is the alcohol part. Now, usually when they write the alcohol part, this is how it is normally put it. They just have it reverse. This H, this B on this side, and this OH, this B on the other side, meaning it is look like this. Normally, they just write it like this. Give me a few seconds. The OH will be on this side, and this H will be on this side. So that's how it is normally draw and alcohol. That's the full structural formula. However, obviously the OH comes first and the H comes after. It's still the same ethanol, obviously. However, whenever you're doing esters, it makes it easier if you put the OH first. It just makes it easier to do the so-called calculations. So when you mix an acid and alkanoic acid and ethanol, you will get this thing called the ester. So this here is the ester that's been created, and you also get some water. This here is the water, obviously. But it might be hard to see how these two combine. What's going to happen is that this OH here from the alkanoic acid will mix with this H over here. These two will combine and leave the structure. Now, you'll realize this is two H's, 1, 2, and an O. So you get what? H2O. But this is the correct thing I'm telling you. But some people will see this another way, right? There's no, sorry, I made a mistake. There's no other way to see this because you need H2O. Just remember, it's one H coming from the alcohol and the OH comes from the ethanoic acid, right? Or the other way, of seeing it, and this is the wrong way, right? Some people is mix it up like this. They will say that the OH comes from the alcohol and one H comes from the alkanoic acid. Now you all realize this still gives you what? H2O. But this is actually wrong. It's the other way around it. And I found a way to memorize it, right? So who is being stingy here? Is the alkanoic acid being stingy, or is the ethanol, the alcohol, being stingy? Who is being stingy in this case here? Who is donating less to create the water? The alcohol, right? The alcohol is the selfish one. I spell selfish kind of S-E-L, right? Alcohol is the selfish one because he donates only one each, while the ethanoic acid says, I will give up two things. And the way I remember this is that how this is the alcohol. Alcoholics are selfish, right? You ever see a true alcoholic when he has a bottle of rum to drink, he hides the bottle. He doesn't want to share it. I've seen that in real life, so that chimes into my head, right? So just remember, alcoholics are selfish and they will share less. Okay. So when these two move out now to form the water, look, the water is here. This will combine with the remaining structure. So look at it. This straightens up a little bit. You notice it was slanted here. It straightens up here. And this O here comes and bonds with this C. All right? So it's like a merger between the two now. And this part here is the alcohol part, the part that box off alcohol. And this part here is the acid part, the alkanoic acid. You notice the alcohol has two C's. So he is F. So you started with F and it ends with YL. The acid is also Et. He has two C's, but his part of the name ends with anoate. Someone asked if it's okay to put the ethanoate part first. The answer is no. The alcohol part of the name has to come first. Even though in the structure, the alcohol part comes second. Look at it. The acid part comes first here, and the alcohol part comes second. But when you're naming it, the alcohol name part comes first, and the acid part comes after. Kind of unfair, right? I mean, if the acid came first, why he didn't put his part in the name first? And that is what has confused a lot of people. Right? So guys, adjust your diagrams. Put in what I put in there in red. Right? Don't worry, we have a little practice question. Don't worry. Nope, the reactants do not need to have the same amount of carbons, right? This is pure coincidence. Give me a few seconds. Let me get a green here, right? It is just pure coincidence in my first example that this had two C's and this also had two C's. So both of them started with F. You're going to see in our next example that they don't always have to have the same amount of C's. Right, so let me know when you guys are finished. All right. What word are we trying to say here? I'm not realizing how I've seen it on in class, how easy this is. Oh, Lord. What set? No. Samir correct, Riza correct, Isaiah correct. Alia correct. All right. Salamatu correct. Caitlin correct. All right. I give up. This one too easy. I hope. What? No set. The word is trunk. All of them displaying a trunk, a tree trunk, an elephant trunk, a car trunk. Oh, Lord. All right. Let's go. Let's go. All right. So you think you all can do this one for me? With this one, we're mixing methanoic acid, right? Notice the alkanoic acid only has one C, and we're mixing it with ethanol. Now, I want you to draw the final structure, and I also want you to name it. So it's a draw and name the ester without looking back in your notes, right? Send your answers. Well, I know you won't be able to send the drawing, but at least send the name across. Good luck. I await your answers. I think everyone who sent an answer got it correct, but let's make sure. This here is the diagram, right? Now, I drew it this way on purpose, right? You don't always have to straighten out this. So if you have this, right, it would also be correct. You could straighten out the double bond here with the O, and this here, or everything here could swing upwards like this, if you want, right? But you don't have to. You could draw it slanted downwards. So all of these answers here are correct. 1 second, guys. Right. All right. So how much of you all had the structure correct? It doesn't matter if you had it straight. That's correct. If you want to be fancy and swing this whole thing downwards to get this, it's also correct. Right. Now, if you look at this now, the alcohol part in the drawing comes second, right? So this here is what? The alcohol part, and it has two C's, so he is ethyl, the alcohol part, and the acid part has one C, so he is meth, and it ends with a, no, it, right? That's the name of the ester, and that is what I saw on the chat from the majority, well, all the students who submitted. Right, so for anybody who got it wrong, I'm giving you half a minute. I'm moving on. Right, but if you got it out, feel real good about yourself. Feel real good. All right. So sometimes they ask you to do it from scratch now. And you have to do this question. I'm not drawing the propanoic acid and I'm not drawing the butanol. So you have to start the diagram from scratch, draw propanoic acid, draw butanol, mix it, and then tell me what you get for the ester and also name the ester. All right, so I'm going to give you 5 minutes for this one. All right. So, yeah, the first thing, that's the answer below there, right? But the propanoic acid, right? Number prop means 3. So it was 1, 2, 3. This one would have an H here, H, 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 and the last one would have double O and the O and the H here. That's the propanoic acid. Now, butanol, but is what? 4. So it's 4 carbons, right? Draw everything out here. All right. Now, usually I would put what? The OH on this side, but when I'm dealing with esters, I'm going to put the OH on this side and the H over here. And as I mentioned, the butanol is going to be, the alcohol is going to be the stingy one. So he's going to give up one H, while the propanoic acid is going to give up a H and a O. And that forms your H2O. And you all can see it here, the structure here. And the alcohol part is but, so it's BUTYL. And the alcohol, sorry, the acid part is PROP, no it. And I think it's supposed to be LY. It's supposed to be YL or LY. You all can remember? Oh God, my memory. So, do I have it correct? Was LY or YL? All right, so I have it correct. Somebody else had LY. Is the Y before the L, right? So for the person, just correct that little thing there, right? The Y comes before the L. All right, so based on the answers that came across, it seems like all the answers I saw were basically correct. All right, so take a 20 seconds and we're going to move on. By the way, the name of this process is esterification because we are creating esters, right? There's an opposite procedure. Anybody remembers from the homework? What's the reverse of esterification? If you reverse the process, like you start off with an ester and you work backwards, it starts with the letter H. Do you all remember from the homework? What's the opposite of esterification? Right, Reza, correct. Right. For those who don't know, you will see the name in a little while. How about this one? I hope this one is hard enough. What word am I trying to portray here? It's 1, 2, 3, 4, 5, 6, 7, 8 letters long, and the third letter is O. Samir, correct, by the way, with your guess. What word is this? Does this make sense? Everything there's about a tropical island, pineapple in the ocean, you know, all of those things are associated with the word tropical. So I'm glad this one was hard. And it gave you all something to think about. Let's move on. Right, so the word is hydrolysis. Hydrolysis. That's the opposite of esterification. So you can imagine, right, in most of the hydrolysis reactions, if what is it? You're going to take an alkanoic acid, you combine it with an alcohol, and when you do that, you get an ester plus water. But esterification is this way. In hydrolysis, when you reverse the process, you start off with the ester. And in most cases, well, in one of the cases, you will get back your alcohol and alkanoic acid. So obviously that is what it means by reversing it. You will get back the two original compounds that was used to make the ester in the first place. So let's see some of that here. Hydrolysis. There are two types of hydrolysis. One called acid hydrolysis. So what you're going to do is take the ester and you're going to boil it with water and a dilute acid, such as H2SO4 or HCl. And here we're going to start off with the ester ethyl ethanoate. Now, just to remind you, right? The one with the YL is the alcohol part. And the second part, the one with the anoate, is from the acid part. Well, the alkanoic acid. I'm just going to write the word acid. So, obviously, if you do this process, the acid that you're going to get back is the ethanoic acid and the ethanol, right? Also, if you're seeing a H plus here, this H plus is from the HCl or H2SO4. Remember, HCl has a H plus and a Cl minus. This H plus is from the acid part. That is what the H plus here means here. All right. So this one is pretty easy, right? Take down everything on the screen. And write it back on screen. Right, so this is acid hydrolysis. Obviously, the reason for its name, we're boiling it with water and, more importantly, an acid. But there's another type of hydrolysis, right? Right. Oh, by the way, before we go to this one, if we start off with methyl propanoate, this is the name of the ester. We're still doing acid hydrolysis. Anybody wants to tell me what two products we're going to end up with? Right? Send it to me. I want the name of the acid, the original acid, and the original alcohol. Right. So well, remember the first part of the name, the part that ends with YL, is the alcohol part. And the other part, the one that ends in anoate, is the alkanoic acid part. So I always like to write the acid name first. So he's propanoic acid, and the alcohol would be methanol. That would be the answer, right? Judging on the answers here, real people got it correct. Right, so take a 30 seconds, take down what you need to, and we're moving on. Oh, I have the answer here in any case. And I drew out the structures and whatnot. But there was no need to draw it out, but this is what you would have gotten. Oh, this one here is a hard one. What do you all think about this one? It's a word that starts with R, and it's 1, 2, 3, 4, 5, 6, 7, 8 letters. It's reaction. Look at all of them. It's a reaction. All of them are depicting some sort of reaction. So if you didn't know, now you know. Right. So the other one is alkaline hydrolysis. Now, alkaline hydrolysis is different for a couple of reasons. It's different from acid hydrolysis. Alkaline hydrolysis obviously means instead of mixing it or boiling it with an acid, you're boiling it with something that's alkaline in nature, meaning that it has a pH of more than 7. So things like potassium hydroxide or sodium hydroxide, right? All of those are alkaline in what? Nature. So you're going to boil the ester with that. But when you boil the ester with that, you don't actually get back the original alcohol and the alkanoic acid as in the previous one. In this one, when you do the procedure, you will end up with the alcohol, but instead of the alkanoic acid, you end up with what? The salt instead, right? So take down everything here. Take it down, right? And of course, I'm going to show you some examples of alkaline hydrolysis. This one is a little headache to understand. Let me know when you're finished. Right. So look at this complex situation, right? I circle the things that I want you to focus on, right? So you're going to start off with the ester, right? Now remember, you're boiling the ester with two things. You're boiling the ester with water and something alkaline. So this is what normally happens. The ester will react with the water first. And well, remember, water contains OH in it. So forget these little things over here for the time being. I'll just complicate it. So when you mix the ester with the water, these two will react to give you your alkanoic acid and alcohol. So at first glance, it seems like I was talking nonsense, right? Because I told you for this process, we're supposed to end up with the alcohol and the salt. But it seems that we end up with the alcohol and the alkanoic acid. But the reaction is not complete. Remember, we're mixing it with water and the salt, okay? So what's going to happen now? The alkanoic acid that was just created in the same test tube will start to react with the alkaline substance, the NaOH. And when that happens, you no longer have an alkanoic acid. It reacts with the NaOH to give you what? The salt and water. So in the test tube, you end up with alcohol and salt, and you get some water. But they already don't mention the water in the final reaction, right? So just remember, at first, you get the alkanoic acid, but then the alkanoic acid reacts afterwards with the alkaline substance. And so that is why when you take an ester and you mix it with something alkaline, you get salt and alcohol. You don't actually get back the alkanoic acid. You could think of it as getting the alkanoic acid temporarily, but eventually that's going to disappear from the reaction and it's going to turn into a salt. All right? I want you to take down everything on the screen again. Right? And I think I have an example with actual substances, real substances. So this was solidified in your head. All right, so to make this simple, right? We're going to take, this here is an ester, in case you didn't realize. This here is an ester. Now the ester, you can break it up into two pieces. Remember, piece would have come from the alcohol and piece would have come from the ethanoic acid. The best way to kind of split it up, you see after the two O's, you could imagine that there's a little dash line here. Everything before the dash line came from the alkanoic acid. And everything afterwards came from what? The alcohol. Because remember, it has an acid part and an alcohol part. So after the two O's, you can imagine an imaginary division line there. So what's going to happen, right? This CHCOO part, this part by itself has a charge of -1. And the alcohol part, the whole thing, has a charge of +1. So what's going to happen? Remember, sodium and hydroxide. We all know sodium has a charge of +1 and OH has a charge of -1. And that's basic chemistry. What's going to happen is that when you mix it, the sodium is going to try to kick out the alcohol part. The poor alcohol can't get a break, right? He's stingy and now he's going to get kicked out. So you'll realize that what happened, this is exactly what happens after the reaction. Look at it. The blue part gets kicked out and replaces by the red part. And it's a perfect exchange because the C2H5 is +1 and the Na is +1. So when the sodium takes the place of the blue part, the acid part is not going to know the difference. All he knows is he has another item that has a charge of +1 to take its place. And of course, the blue part goes to meet what? The OH that the sodium defected from. So obviously this part here is the salt part. And since the blue part gets back the OH part, he becomes what now? The alcohol part. Right? So take down everything there. So that's an example of alkaline hydrolysis. All right, let's go. All right. So the next one here is something called the saponification of esters. Obviously, this is how they create soaps. So saponification of esters is actually a type of alkaline hydrolysis, but a more complex version of it. But you're going to see the same traits. So what you're going to do is start off with an ester. Now, I know this is not a normal looking ester. I know you don't have to memorize this reaction. The examiner will start you off with it, and you might just have to what? Balance it off. But I want to show you all some sense with this, right? So if you look over here, right? Check it out. Before we knew this was tree and this was tree and whatnot, I want to show you how they reason that out. So let me erase a few things here. Let me erase this tree here, erase this tree here, right? So like I said, the ester part after the COO, right? I want you to divide it over here, right? So that's a little division here. So you know this part is really what? It came from the alcohol part. And this part is really what? The alkanoic acid part, right? It's just a very complicated ester. So then you're going to mix it with what? Sodium hydroxide. Now remember the acid part, one of this, I know they have three over here, but the part inside the brackets is -1. And the alcohol part, the C8, the C3H5, he's +1. So obviously the sodium is going to try to kick out what? The alcohol part. And he does. So the alcohol part gets kicked out and he joins the OH, right? But remember, when the sodium, sorry, I made a small mistake here, right? Remember, if the part inside the brackets is -1, this alcohol will have a charge of how much? Think about it. I made a slight mistake. The part inside the brackets is -1, and you have 3 of it. So the overall charge of this is -3 because you have 3 negative ones. What is the charge on the alcohol part? Who could tell me what the charge on the alcohol part would be to balance that off? Right. The CH3, the C3H5, sorry, will have a charge of +3. So that means if the alcohol part has a charge of +3, when it meets the OH part, remember OH has a charge of -1. So it will need how much of it to balance it off? 3. So that's why you have OH in brackets and a 3 here. Okay? Also, when the sodium goes over here, sodium has a charge of +1. So when the sodium goes over here, it will need 3 of him to balance off 1 of this. So what they did, right, is that they put the 3 in front. They moved this 3 and put it in front. So that means you have 3 of the guy in the brackets and you have 3 of the sodium. So the 3 belongs to all of them. They're obviously not going to write it like this, right? C17H35 COO and put he as 3 and then put sodium as what? tree. They don't do that in chemistry. If both of them have a small tree here, they move and put the tree in front. So that means the tree will belong to both of them at the same time. Right? Just always remember the after the part with the COO, he's always -1. This part is always -1. The charge on the alcohol part can change to suit. Right? So I needed to take down that one. And this is how they create soaps. You see this thing they created here? That's your soap. Right? That's soap on purification. Right? And these are the conditions on top, obviously. Right? You have to boil it with concentrated sodium hydroxide. All right, so let's do a last one here, guys, and we're out of here. And next week will next week will be the last week on organic chemistry, and after that, as I promised, it's just past papers. We're gonna hit off past papers after past papers, and let's see how much we can get done between now and exams. And guys, we're going up straight to the day before exams, even in multiple choice. So most likely we're going to the end of May. And try not to miss those classes. I know it's going to be in between exam time, but please don't miss out on the past paper work, right? That's the important part. Everyone got this one correct. I swear I have to make these games harder. No, Josiah. At least one person got it wrong. I'm feeling good about myself. The answer is mammals. All of these creatures in front of you, rabbit, whales, and elephants, are all mammals. Yes, a whale is a mammal. All right, guys, I'll see you all next week. Try to get some rest over the weekend. All right. Hope you don't have too much work to do. Have a good one, guys.